Are we entering a sixth mass extinction event? Life on Earth has persisted for more than 3.5 billion years. In that immense span of time, the planet has changed beyond imagination. Continents have collided and drifted apart. Climates have swung from frozen wastelands to stifling hothouses. And creatures of every form have risen, only for the vast majority to vanish again. But on 5 occasions, the very rhythm of life faltered catastrophically. Entire worlds of living things collapsed, leaving only a fraction of species to carry evolution forward. These events are called mass extinctions, intervals when more than 3/4 of Earth's species perished in a geological instant. Collectively, we know them as the Big Five, the most devastating chapters in the history of life. In this film, we journey through deep time, exploring the 5 great die-offs that reshaped the story of life, global cataclysms without which we might never have evolved. We will ask, what forces could erase so much so quickly? What remarkable survivors inherited the Earth? And most urgently, could it be that, under our own watch, a 6th extinction has already begun? If the deep history of our planet fascinates you, consider liking and subscribing now, so these stories of Earth's past and future can reach even more curious minds. Now, let us travel back to see what we can learn from the most turbulent eras in Earth's past. Extinction is not unusual. In fact, it is the rule. More than 98% of all species that have ever lived are gone. Normally, these disappearances occur at a slow, constant background pace, perhaps a single species vanishing out of every 10,000 in the span of a century. Life's creative force, through random mutation and the patient work of evolution, usually outpaces such losses. But a mass extinction is something altogether different. It is a crisis interval when species vanish far faster than new ones can appear. Scientists define it as an event that erases at least 3/4 of Earth's species in a geologically brief moment, less than 3 million years and sometimes much less. These catastrophes stand out in the fossil record as sharp breaks, brief intervals of global collapse when ecosystems disintegrated on both land and sea. They are the punctuation marks in Earth's story, rare, devastating and transformative, warnings of the impermanence and fragility of life, even for the most dominant species. Over the last 500 million years, 5 such calamities have been identified. Known as the Big Five, they serve as milestones in understanding how life can be brought to its knees and how it rebounds from near-total destruction. Each was driven by extraordinary upheaval, climate chaos, plunging seas, cataclysmic volcanism, or impacts from space. And each reset the course of evolution, erasing the dominant groups of their time and opening the way for new ones to rise. 443 million years ago, life on Earth was still confined almost entirely to the oceans. Vast coral reefs stretched across shallow seas, trilobites scuttled along the seabed, and delicate creatures called graptolites floated in drifting colonies. Colonial, plankton-like animals that traced fine, saw-toothed patterns in black shales. Brachiopods, shelled animals resembling clams, were among the most abundant forms of life. It was a world rich with biodiversity, and then, suddenly, most of it was gone. This was the Ordovician Silurian Extinction, the first of the great die-offs. In 2 sharp pulses, nearly 85% of marine species disappeared. The cause was dramatic climate upheaval. As the ancient supercontinent of Gondwana drifted across the South Pole, vast ice sheets spread across its surface. Global temperatures plunged, locking away water as ice and causing sea levels to fall by more than 100 meters. Shallow continental shelves, home to much of life's diversity, drained away. Whole ecosystems collapsed, coral reefs crumbled, trilobite lineages that had thrived for 100 million years vanished forever. Graptolites, once prolific in the oceans, dwindled almost to extinction. Then, as the Ice Age ended, a geologic heartbeat later, perhaps just 500,000 years after it began, the pendulum swung violently the other way. Glaciers melted, seas surged back, and Earth lurched into rapid warming. Oxygen levels in the oceans plummeted. The survivors of the first blow were struck down by the second. In less than 2 million years, this one-two punch had erased most of the species that filled the Ordovician seas. Yet amid the devastation, some lineages endured. Tiny ancestors of modern jawed fishes survived, and new coral groups would one day build reefs again. Out of the ruins of the Ordovician world, life slowly began to diversify anew in the Silurian seas. Over the next 50 million years, the oceans blossomed again. Brachiopods and corals rebuilt reef communities, and jawed fishes, newcomers that had barely survived the Ordovician crisis, diversified rapidly. By the early Devonian, primitive sharks cruised coastal shallows and lobe-finned fishes experimented with stronger fins and rudimentary lungs. On land, the first vascular plants rooted along riverbanks, stabilizing soils and greening Earth's shorelines. Insects and early arthropods soon followed, knitting together the planet's first terrestrial ecosystems. This flourishing world, rich with innovation in sea and on land, set the stage for the Devonian, the famed Age of Fishes. 374 million years ago, the seas of the Devonian teemed with life. Vast reef systems, rivaling the size of today's Great Barrier Reef, were built not by modern corals but by stromatoporoids, sponge-like reef builders creating immense marine citadels. Placoderms, armoured fishes like Dunkleosteus, stretching 6 meters long, prowled these reefs as some of the ocean's first super predators. Lobe-finned fishes, ancestors of future amphibians and mammals, flourished in the shallows. By the Middle Devonian, fishes accounted for more than half of all known vertebrate species on Earth. From these plate-mailed hunters to the earliest sharks, and from delicate ray fins to sturdy lobe fins poised to crawl onto land, the seas swarmed with vertebrate life in astonishing variety. Never before had a single group so thoroughly dominated the oceans, but by the close of the Devonian period, this vibrant world had all but collapsed. The extinction was not one single crash, but a drawn-out series of crises lasting nearly 20 million years. In wave after wave, biodiversity declined until 3/4 of all known species were gone. The reasons remain a puzzle, but the evidence points to environmental chaos. Sea levels rose and fell repeatedly, drowning coastlines and stranding reefs. Ocean chemistry shifted, with oxygen levels plummeting into repeated episodes of anoxia, suffocating the sea floor. Without oxygen, the microbes that normally break down the dead could not. Organic rain piled up on the sea floor and over time compressed into thick bands of black shale, a stark geological signature of ancient dead zones. Some scientists suspect that the explosive spread of the first great forests on land played a part in the extinction. Vast root systems weathered rock and sent nutrients rushing into the seas, triggering algal blooms and further depleting oxygen. Others propose massive volcanic eruptions or even impacts from space as possible triggers for certain extinction pulses. Whatever the precise causes, the effects were devastating. Reef-building stromatoporoids disappeared forever. Placoderms, once dominant predators, perished entirely. Many lineages of lobe-finned fishes, though not all, vanished. Even trilobites, already struggling, suffered heavy losses. The age of fishes came to a quiet end, and for tens of millions of years afterward, the oceans lacked the great reef systems that had once dominated them. Life would recover, but the world of the Devonian seas was gone forever. Over the next 60 million years, Earth's biosphere rebuilt itself in striking new ways. Coal swamp forests of giant club mosses, horsetails and seed ferns blanketed the lowlands, drawing vast amounts of carbon from the atmosphere and laying down the coal seams we mine today. These dense forests sheltered a surge of giant arthropods, dragonflies with 70-centimetre wingspans and millipedes a metre long. Amphibians diversified, some evolving into massive crocodile-like predators patrolling carboniferous rivers. And in a quiet evolutionary leap, early amniotes, the first vertebrates to lay eggs on dry land, appeared, freeing reptiles and their descendants from dependence on water for reproduction. By the Permian, these pioneers had produced a rich array of synapsids, ancestors of mammals, including early sail-backed predators like Dimetrodon and later saber-toothed Gorgonopsians, alongside diverse early reptiles that roamed the sprawling landscapes of Pangaea, setting the stage for life's next great trial. Beneath the waves, corals, brachiopods and trilobites flourished as they had for hundreds of millions of years. At this late Permian peak, life's diversity reached unprecedented heights. Oceans hosted the richest marine communities of the Paleozoic, while on land, sprawling forests and a multitude of reptiles and synapsids formed intricate ecosystems. And then, almost without warning in Earth's vast history, that vibrant world fell silent. This was the Permian Triassic Extinction, known as the Great Dying, the most severe biological crisis in our planet's history, nearly extinguishing complex life entirely. In a geologic instant, at least 95% of all species vanished, entire ecosystems disintegrated. Among the many casualties, the last of the trilobites, a group that had survived for 270 million years, disappeared forever. Marine life suffered worst of all. More than 96% of ocean species were lost. Coral reefs collapsed yet again, vanishing entirely from Earth's oceans for several million years. On land, 70% of species perished, including most large amphibians and reptilian lineages. Forests withered, and even the insects, normally resilient through life's catastrophes, crashed. Entire lineages vanished. The once diverse Paleodictyopterans disappeared completely, and several ancestral beetle groups dwindled. This was the only mass extinction in Earth's history to cause a major collapse of insect diversity, a sign of just how severe the Permian crisis was. What could cause devastation on such a scale? The answer remains debated, but evidence points to cataclysm. In Siberia, one of the largest volcanic events in Earth's history erupted for nearly 1 million years, releasing enough lava to blanket an area larger than the United States, hundreds of meters thick on average, and piled to several kilometers in places. Alongside the rock came unimaginable volumes of greenhouse gases, carbon dioxide and methane, that drove global temperatures soaring. Oceans warmed, acidified, and suffocated as oxygen levels collapsed. Some scientists argue that an asteroid strike may also have played a part, darkening skies and poisoning the atmosphere. It's possible that both forces, cosmic and volcanic, combined to deliver a killing blow. Whatever the exact cause, the results were apocalyptic. Coral reefs gone, trilobites gone, most insects gone. For a brief moment, fungal spores dominated the fossil record, feeding on immense fields of rotting plants and animals that carpeted the barren world. But their dominance was short-lived. Once the dead biomass was consumed, even these hardy decomposers waned, leaving a planet eerily quiet. Life on Earth very nearly ended. It would take tens of millions of years for biodiversity to recover. In many ways, the Permian extinction was a reset button for life, clearing the stage for entirely new evolutionary paths, including the eventual rise of the dinosaurs, the most iconic of Earth's vanished lineages. In the long recovery that followed, new reptiles and amphibians diversified to occupy the emptied niches. Among them were the Archosaurs, a broad lineage that would give rise to both crocodiles and dinosaurs. Conifers and cycads spread across Pangaea, greening the landscape and providing food and shelter for evolving herbivores. In the seas, sleek marine reptiles began to patrol the coasts, while smaller seagoing cousins and early fishes rebuilt the shattered food webs. By the Middle Triassic, ecosystems were thriving once more. But the balance of power had shifted, and the stage was set for another upheaval. 201 million years ago, the supercontinent Pangaea stretched nearly pole to pole, stitched together by vast deserts and rimmed by shallow seas. Reptiles of every shape prowled its coasts and river valleys. Early dinosaurs existed, but were still minor players among the dominant crurotarsans, crocodile-like archosaurs, and enormous amphibians. Mammal ancestors scurried in the underbrush, while in the oceans, ichthyosaurs and plesiosaurs glided through warm waters. Then, in a geological heartbeat, the world convulsed in sudden violence. As Pangaea began to break apart, colossal volcanic eruptions tore across what is now eastern North America, northwestern Africa and Europe. These eruptions formed the Central Atlantic Magmatic Province, one of the largest volcanic outpourings in Earth's history. Over several 100,000 years, enough basalt flooded the land to cover an area the size of modern Europe, and billions of tons of carbon dioxide and sulfur gases were pumped into the atmosphere. The result was climate chaos, rapid global warming, ocean acidification, and severe disruptions to habitats worldwide. Roughly 80% of species vanished. Many reptiles, amphibians, and even early dinosaur relatives perished. Entire marine ecosystems collapsed once more, but some lineages endured. A few small dinosaur groups, lightweight, fast-growing generalists with efficient upright gaits and flexible diets, survived the upheaval, traits that let them weather rapid climate swings and shifting landscapes when more specialized rivals perished. Early mammals, too, held on. Though tiny and nocturnal, these shrew-like creatures possessed warm-blooded metabolisms, keen senses, and flexible diets that allowed them to survive in the shadows while giants perished. With so many competitors erased, they crept into abandoned niches, scavenging, hunting insects, and quietly multiplying. These unassuming survivors are our distant ancestors, small, soft-furred threads of life that endured the storm. From their persistence, the great branches of mammals, including primates and eventually humans, would unfurl. In a very real sense, this is where our own story begins. The Triassic-Jurassic extinction cleared the stage for dinosaurs to dominate the Jurassic period, setting them on a path to become the most iconic of Earth's vanished lineages. In the long calm that followed, dinosaurs radiated into an astonishing array of forms, immense sauropods, agile theropods, and plated herbivores that occupied nearly every terrestrial niche. Pterosaurs mastered the skies, while marine reptiles like plesiosaurs and ichthyosaurs patrolled the seas. Mammals, though still small and nocturnal, quietly refined traits: fur insulation, acute hearing, and live birth that would one day prove vital. Conifer forests and the first flowering plants reshaped landscapes, enriching food webs and driving new evolutionary arms races. By the late Cretaceous, Earth had become a lush, dynamic world, primed for the next great cataclysm. 66 million years ago, Earth was a vibrant world of towering forests and blooming landscapes, warm inland seas, and dinosaurs roaming every continent. For more than 160 million years, dinosaurs had not merely survived but dominated the planet, one of the longest and most spectacular reigns in Earth's history. Triceratops grazed beneath ancient forests, while pterosaurs glided overhead and mosasaurs hunted in shallow oceans. Then, in a single shattering moment, the age of giants was undone. A mountain-sized asteroid, roughly 10 kilometers across, slammed into what is now Mexico's Yucatan Peninsula. The impact released energy equal to billions of nuclear bombs, heaving shockwaves across the planet and blasting a shroud of rock vapor into the atmosphere. Day turned to night as sunlight was blocked for months, perhaps years. Temperatures plunged. The catastrophe was not a single blow. In India, the Deccan Traps, an immense flood basalt province, had already been erupting for hundreds of thousands of years, pumping greenhouse gases into the air and stressing ecosystems. But the Chicxulub impact was the decisive trigger that pushed Earth past the breaking point. Around 75 to 78% of species vanished. Nearly all land animals heavier than 25 kilograms perished. Non-avian dinosaurs were gone. Flying pterosaurs disappeared. Great marine reptiles like mosasaurs and plesiosaurs vanished. Even many invertebrates suffered. Ammonites, spiral-shelled cephalopods that had survived earlier crises, disappeared completely. A global rain of molten rock and glassy spherules, material blasted into space and superheated on re-entry, cascaded through the skies, igniting continent-wide wildfires. Acid rains drenched the land and seas, and food chains everywhere collapsed. Within hours, unshielded life across the continents was seared by this fiery fallout. Yet the true extinction, the loss of 3/4 of species, unfolded over months to millennia as darkness and famine gripped the planet. In the aftermath, with the dinosaurs gone, the world belonged to the survivors. Small mammals, birds, the only living dinosaurs, and flowering plants began to proliferate. From these survivors, new lineages would rise, and among them, the distant ancestors of humankind. But Earth's story doesn't end with the dinosaurs' fall. Today, scientists warn that another mass extinction may already be unfolding. One, unlike any before, driven not by asteroids or volcanoes but by us. Tune in next time as we explore the evidence for a sixth extinction, what's fueling it and what choices remain to change the ending.